Hello dear students, as you all know we have done chapter number 10 wave optics. So today we are going to start chapter number 1 electric charges and fields. The numericals of chapter 10 will be discussed after 2 or 3 days. In this time you have to solve numericals by yourself, and then after you will tell me in which numericals you are facing problem. We will discuss those. If I do not receive any query, then I'll solve some selected numericals of chapter 10. Today we are going to start chapter number 1, and that chapter is electric charges and fields. Today we are going to discuss charges, definition and properties. Second thing, method of charging a body. And third thing, problems based on quantization of charge. So let us start. The first thing we are going to study is electric charge. What is electric charge? So charge is basically, you must have heard in the class 10th that charges are two type, negative and positive. Okay, negative, positive, attract, positive, repel. So many things about charges. But what is the charge? How we define the charge? The definition of charge is actually, charge is that property of an object by virtue of which it applies electrostatic force of interaction on other objects. Basically, charge is a property, and it is the property of elementary particles. When I say elementary particles, I want to say that electrons, protons, which made up body. A body is made up of atoms, and atom is made up of electron and protons. So when I say elementary particles, I mean to say electrons and protons. So basically, charge is the property of those particles because of which they apply a force which is called electrostatic force on each other. Okay, so this is what the charge is. Now let us discuss some important points regarding the charge. The first point is, charges are of two types, positive and negative. Okay, all we know that protons are positively charged and electrons are negatively charged. The second thing, like charges repel and unlike charges attract each other. Like charges, if they are proton, if they are electron, then they'll repel each other. Whereas one proton, one electron, one positive, one negative, or one electron, one proton, one negative, one positive, they'll attract each other. Now, about neutral bodies. Neutral bodies are attracted by both positive and negative charge due to induction. What is induction? Induction is the property by virtue of which a body develops charges to the nearby surface when a charged body put near to it. Okay, we'll discuss electrostatic induction today in a detailed manner, but here the point is the neutral bodies are attracted by both positive as well as negative. So positive attracts neutral body and negative also attracts neutral body. Let us move ahead. Next point is, charge on electron proton is minimum and it is represented by minus E and plus E respectively. The charge presented on electron is minus E and charge presented on proton is plus E. But in advanced nuclear research, which is our next point, in advanced nuclear research, it is suggested that proton and neutron, which are inside the nucleus, they are composed of basic units, and that basic unit is called quark. Okay, proton is itself made of some particles, and those particles are called quark, as well as neutron also. Neutrons are made up of those particles, basic particles, and those basic particles are called quark. Now quark are of two types, and they are up quark and down quark. So quarks have charges minus 1 by 3e, which is called down quark, and plus 2 by 3e, which is called up quark. Okay, when we talk about proton, the proton is consist of 2 up quark and 1 down quark, UUD. And when we talk about neutron, it is composed of 2 down quark and 1 up quark, DDU. Is it clear? When we add the charges, you will get the charge of proton, and for neutron the total charge becomes 0. Okay, now let us move ahead. Next point is quark do not have independent existence. Quark cannot exist in the vacuum. They exist inside the nucleus only, and that is why when we talk about charges, we do not count quark. Is it clear? Quark is inside the nucleus only. It is not there in the vacuum, and it is not transferable from one body to another body. So that's why when we talk about charge, we don't count quark. Okay, now we'll go talk about a neutral atom. The number of electrons being equal to the number of protons as an atom is neutral. In an atom, the atomic number shows the number of protons, and if it is not ion, if it does not become an ion, the number of electrons is equal to number of protons. The number of electrons, since the number is equal, therefore the charge is also going to be equal, but the charge is opposite also. That because of that, an atom is neutral. Okay, suppose we talk about oxygen. The atomic number of oxygen is 8. That means it has 8 protons and 8 electrons. Total charge of 8 protons is 8e, and total charge of 8 electrons is minus 8e. When we add up them, the total charge becomes 0. Then atom of oxygen is neutral. Now let us move ahead. If the electrons are removed from a body, it gets positively charged. Okay, when a body is lack of electrons, it has deficiency of electrons, so it will become positively charged because number of protons will become greater than number of electrons. Okay, the positive charge is more than the negative charge, and that's why the body becomes positive charge. Whereas if a body has excess electron, then the body is negatively charged because number of electrons is more than number of protons. Then what happens? The total negative charge exceeds the total positive charge, and therefore the body becomes negatively charged. So this is about charge. Now we are going to discuss property of charge. Properties of charge. There are 3 properties, and every year, most of the time, one question is there from the properties in the board examination. So you must understand all the properties. Let us go one by one. The first property is quantization of charge. What is quantization? Quantization means to divide the given specific amount in a small units, in a small fixed units. It is called quantization, and one unit is called quanta. Okay, so here the charge on a body, as we have discussed earlier, it can be there because of removal or addition of electrons, and electrons are always added or removed in integral number, and therefore the charge on any object can be an integral multiple of a smallest charge, and that the smallest charge is E. So what we say, that charge on a body is given by Q is equal to plus minus Ne, where N is an integer and E is the charge present on one electron, which is given by 1.6 into 10 to the power minus 19 coulomb. Okay, so Q is equal to plus minus Ne. When the electrons are added, then it becomes minus Ne because charge on electrons are negative. When electrons are removed, it becomes plus Ne because removal of electrons leads to positive charge. Okay, so this is what the quantization means. Quantization means the total charge on a body can be divided into integral number of charge present on one electron. So that unit, that quanta is a charge present on one electron, and that is given by 1.6 into 10 to the power minus 19 coulomb. Okay, now come to the second point. Second point is about conservation of charge. When we hear this word conservation, the first thing we understand is conservation of energy. It is taught in very earlier classes, and we all know what is the statement of the conservation of energy. Energy can neither be created nor be destroyed. So in the same manner, the conservation of charge is also there. Charge can neither be created nor be destroyed. What it can be, so it can be transferred from one object to another object, one body to another body. Okay. In other words, the conservation of charge can be stated as the whole amount of charge present in the universe. The charge present in the whole universe remains constant, because we can neither create. If we cannot create, we cannot increase the amount, and if we cannot destroy, we cannot decrease the amount also. So what happens? The amount of charge is fixed, and it is for the whole universe. Okay. The next property is additivity of charge. What is additivity of charge? Additivity means, suppose a system has so many charges. So what is the total charge of the system? Obviously, we'll add the charges, but we have to see that all the charges, we have to see while doing addition, that we have to consider the sign also. So what we should say, the net charge of a system is equal to the algebraic sum of the charges present in the system. Whatever the total charges present in the system, will simply add those charges with their sign, and whatever be the result, will say that is the total charge of the system. Okay, so these are the three properties. The most important properties out of these three is the first one, and which is quantization of charge. We'll solve some numericals today which is based on quantization of charge. Okay, now we are moving to the next, and next is ways of charging a body. What are the ways by which we can charge a body? The first method is charging by friction. What we do, we rub two bodies together. We rub two bodies together. Then what happens? The electrons are transferred from one body to the another body. The electrons are removed from one body to another body. The body from which the electrons are removed, that body becomes negatively charged, and the body to which electrons are transferred, it becomes negatively charged. Sorry, I have said inversely. The body from which the electrons are removed, it becomes positively charged, and the body to which electrons are transferred, it becomes negatively charged. Both the body acquires equal charge but in opposite sign. Suppose if 10 electrons are transferred from one body to the another body, then from one body, on the first body from which the electrons are transferred, it will acquire a charge of plus 10e, whereas the body on which the electrons are transferred, it will acquire minus 10e. Okay, so this is how we charge a body, by using a method of friction. Second thing is charging by electrostatic induction. This thing we're going to discuss in next few minutes. Third one is charging by conduction. Suppose a body is charged, and what we are going to do, we are going to if a body is charged, and what we have to use this method, charging by conduction, then what we do, we take a conducting body and we touch the charged body by the conducting body. Then what will happen? The charge will acquire on the conducting body also. By contact we can transfer the charge. If a body is charged, another body is in contact with that body, is brought in contact with that body, then what happens? That body acquires some charge. So this is the charging by conduction. Now we have to understand charging by electrostatic induction. Let us see what is that. Charging by electrostatic induction. Suppose we have two bodies A and B. A sphere and B sphere both are metallic, but they are on insulating stand. Now we have to use this method, charging by electrostatic induction. Then what we'll do, we'll brought a positively charged body near the sphere A. A and B are the sphere which are conducting, but their stands are insulator. Now what happens, since A is conducting, then all the negative charge which will come nearby the body which is positively charged. So because of induction, what happens, the negative charge is there on the surface of A, and since positive charge is repelled by the body, then what happens, the positive charge will be on B. This is called induction. When we brought a charged body nearby a metal or conductor, then what happens, because of electrostatic induction, the opposite charge comes nearby the surface, and this is what we call electrostatic induction. Now what happens, we separate the spheres A and B. Now A has negative charge, B has positive charge. Now what we do, we remove that body which we brought to make them charge, and now A has negative charge and B has positive charge. If we separate them by a larger distance, then the charge on A will be distributed over its surface, whereas charge on B will be distributed over its surface. So basically, what is induction? If you can see here, the positive charge, when it is brought near, here develops a negative charge. So this is what we say induction. The development of charges when a charged body is brought near by a conducting body is called electrostatic induction. Because negative charges are here, then positive charges becomes here because of repulsion of this one. Is it clear? So this is what electrostatic induction is. Now some important notes regarding the charge. The first one is charge is an invariant quantity. What do we mean when we say invariant? Actually, sometimes what happens, the charge is compared with mass. Mass is also a property. Mass is actually the amount of matter which is contained by a body. And because of mass, there is a attraction force between two bodies, and that force is called gravitational force. There is charge, because of charge also there is a force which is called electrostatic force. Although that electrostatic force and gravitational force are far different things, but there are so many similarities also, like they both follow inverse square law, they both are conservative in nature, they both are natural forces. So many similarities are there. So sometimes what happens, the charge is compared with the mass because of the nature, because of the this point, that they exert force on each other because of charge as well as mass. Now mass is what? Mass is a variant quantity. Mass varies. There is a famous relation of Einstein, and it is called equation of relativity, and it is given by m is equal to m naught upon under root 1 minus v square upon c square, where m is the mass of the body, m naught is called a rest mass. Rest mass means when the body is at rest, then its mass is called rest mass. M naught is rest mass, v is the velocity of the body, and c is the speed of light. M is the mass of the body when the body is moving with the velocity v. In our day-to-day life, v is very less than c. The speed of the object is very less than the speed of the light, and because of that, this v square upon c square becomes almost 0, and m becomes equal to m naught. But for very small particles, this velocity if that velocity comparable to speed of light can be achieved. Okay, so what happens, the m starts varying with increasing value of velocity. If v is equal to c, then m becomes infinity. Okay, so for a very small particle, this equation can be, this velocity can be achieved, velocity comparable to speed of light. So for small particles, the mass starts changing, okay, with the velocity v, but charge never varies. Whether the body is moving, body is at rest, body is in circular motion, body is in rotational motion, doesn't matter, the charge always remains the same. It does not change with the velocity of the body, and that is why it is called an invariant quantity. Okay, now move to the second point. Second point is, the SI unit of electrostatic charge is coulomb, and it is represented by C. The SI unit of electrostatic charge is coulomb, and it is represented by capital C. Okay, Coulomb was the scientist. Third point is, one more unit is there, sometime it is used, and it is called ESU or stat coulomb. The electrostatic of unit of charge is ESU, and it is called electrostatic coulomb, and it is equal to E. Its value is 1.6 into 10 to the power minus 19 coulomb, which is the charge present on one electron. Okay, so this is what the total charge about. Now we are going to solve some numericals today, and then after we'll discuss Coulomb's law in the next lecture. Problem based on electric charge. Problem 1. What is the number of electrons present in 1 coulomb of negative charge? So here the charge is given, that is 1 coulomb, and it is negative. What we have to find out, what is the number of electrons present in 1 coulomb. Okay, now this question you must have solved in class 10th also. Okay, it's a very easy. Let us solve it. Here it is given that Q is equal to 1 coulomb, and we know that E is equal to 1.6 into 10 to the power minus 19 coulomb. Now what happens? Q is equal to NE. That is the formula of quantization of charge. We'll put the values. In place of Q it is 1 coulomb. In place of N will remain that like that only. In place of E it becomes 1.6 into 10 to the power minus 19 coulomb. Now N will be equal to 1.6 into 10 to the power minus 19 is transferred to that side. It will become 1 upon 1.6 into 10 to the power minus 19. When we solve it, we'll get 6.25 into 10 to the power 18 electrons, which is our answer. There is nothing much to explain in this question. It is a very easy one, and you must have solved in class 10th also. It is a very important question. Every time we'll study electrostatics, this is the very first numerical you are going to solve, always. Sometimes this 1 coulomb is replaced by 2, 3, 4, etc. So you can put the charge accordingly. Like question can be, what is the number of electrons present in 5 coulomb of positive charges? So in place of Q you will put 5. One more confusion can be there. Since the charge is given negative, why we have not put it minus 1 coulomb? Actually, we are interested in calculating number of electrons. The charge, whether it is positive or negative, it can be understood with the concept of that whether the charge is removed or whether the electrons are removed or the electrons are added. Okay, so here we are not interested in sign. Here we are interested in number of electrons, and when we put sign, as you can see, minus 1 coulomb and minus 1.6, they'll cancel each other. Is it clear? Now let us move ahead. The second question is, can a body have a charge equal to 4.0 into 10 to the power minus 19 coulomb? Okay, this is the question. Let us solve. Given that Q is equal to 4.0 into 10 to the power minus 19 coulomb, and E value we know that 1.6 into 10 to the power minus 19 coulomb. Now we will solve the value for N. Q is equal to NE. We'll put the value, we'll get 4 into 10 to the power minus 19 coulomb is equal to n multiplied by 1.6 into 10 to the power minus 19 coulomb. For n, we'll solve it and we'll get 4.0 into 10 to the power minus 19 upon 1.6 into 10 to the power minus 19. If we solve it, we are going to have n is equal to 2.5. Now, earlier we have studied that the n is an integer, but in this question when we solve for n, we get 2.5. Obviously that 2.5 is not an integer, and since it is not an integer, that charge is not possible. Okay, this charge on a body is not possible because n is equal to 2.5. This must be an integer. So what we say in the answer? We'll say that since n can only be an integer, therefore the given charge on the body is not possible, which is our answer. Okay, now you must have understand that this question can be asked by changing the value of given charge. So what we need to understand, the value of n should be an integer, then only the charge is possible. If it comes in decimals, if it comes in fractions, then we'll say that the given charge is not possible. Okay, now let us move to the last question of today. The last question is, what is the net charge present in 1 cup of water? Okay, this is the question given in the NCERT in the solved numerical section. Okay, very famous question. Now let us solve it. Solution: let the mass of cup in the water be 250 gram. Okay, this is the value taken in the NCERT. That's why I have taken the same value. You can take it 100, you can take it 150, or whatever you can like, whatever you feel like. But you have to mention what the value you have taken. Since it is not given in the question, you can take anything. Okay, but you have to mention. But take it reasonably. Don't take it 1 kg, 2 kg, etc. Okay, 250 gram, 100 gram, 150 gram. It could be like this. Now mass of water in the cup is 250 gram, and what we need to find out, what are the negative charge, net negative charge present in this amount of water. Okay, let us solve it. First of all, what we're going to solve, we'll try to find out the number of electrons present in the given mass of water, that is 250 gram. How will solve? So first of all, we'll calculate number of moles. The number of moles in 250 gram of water will be, how you calculate? The formula is mass, given mass in gram upon molecular mass. So given mass is 250, molecular mass of water is 18. How it comes out to be? Mass of the molecular formula of water is H2O. The mass of 2 hydrogen atoms are 2, whereas mass of 1 oxygen atom is 16. 16 plus 2, it becomes 18. 250 upon 18, this is the number of moles. Now number of molecules in 1 mole will be equal to the Avogadro number, which is given by Na is equal to 6.02 into 10 to the power 23. Number of moles in the water is 250 upon 18, and in 1 mole there are the molecules 6.02 into 10 to the power 23. So what we'll do, we'll say that therefore the number of molecules in the water will be 250 upon 18 multiply by 6.02 into 10 to the power 23 multiply by, this is the number of molecules. Now in 1 molecule there are 10 electrons. How the 1 molecule has 10 electrons? Try to understand. For 2 hydrogen atoms there are 2 electrons. For 1 oxygen atom there are 88 electrons. So 8 plus 2, how many electrons become? 10 electrons. Number in 1 molecule there are 10 electrons, and the number of molecule is given by 250 upon 18 multiplied by Avogadro number. So what is the number of electrons given? Therefore the number of electron is given by n is equal to 250 upon 18 multiplied by 6.02 into 10 to the power 23. This is the number of molecules. 1 molecule has 10 electron, that it will be multiplied by 10. Now this is the number of electrons. This is the value of n. We have to find out the value of q. The value of n we have calculated. The value of e we all know that. Now what we are going to do, we are going to apply the formula, and the formula is q is equal to ne. We'll put the value of q n, then we'll put the value of e. When we solve it, we are going to have q is equal to 1.34 into 10 to the power 7 coulomb. This is going to be the negative charge present in the 1 cup of water, which is our answer. Now this can be 100 gram of sodium, this can be 100 gram of salt, anything. You have to understand the method. First you have to calculate the number of moles, then you have to calculate number of molecules, then you have to calculate number of electrons, then apply the formula. Okay, this is the procedure how we'll solve the numerical. So this is all for the day. We'll do the next Coulomb's law tomorrow. Let me know whether this method should be teaching on the slide is better or teaching on the board, so that the next video we can make on accordingly. Okay, I'm comfortable with the both. You tell me that in which method you are comfortable. Now one more thing, the notes for chapter number 10, for some parts it was not updated. Today it will be updated by the evening. Part 8, part 9, part 10 and part 11, 4 parts PDF notes were not available. Today it will be updated by the evening, so you must note down. And for this video lecture, all the things which is there on the slides, you must note that these are going to be your notes. Okay, so this is all for the day. Thank you.